Hello, everybody, and thank you for joining us today. Our topic today is investing in AI and robotics, something we're very passionate about here at ROBO Global. We're going to be talking about the technologies that are transforming the economy and how investors can capitalize on these trends. Um, my name is Jeremie Capron, and I'm the Director of Research here at ROBO Global. We are a research and investment advisory company that's focused on robotics, AI, and healthcare technologies. And we are the creators of research-driven index portfolios that are designed to help investors capture the returns presented by this technology revolution. I'm talking to you from New York City, where part of our research team is usually based, and I'm thrilled to be joined today by Professor Daniela Rus, the director of MIT's Computer Science and AI Lab, and a member of the National Academy of Engineering and the American Academy for Arts and Science. And Professor Rus is also an advisor to ROBO Global, and for that, we're very grateful. So with that, I'd like to invite Daniela to the virtual stage and tell us about the future of robotics and AI.
Thank you so much, Jeremie. It's a pleasure to be here with you. Really look forward to talking about where robotics is today and where robots and AI can help. So today we have tremendous technology. We have telepresence that enables doctors to meet with patients safely and students to meet with tutors, even when we're far away. We have robots that help packing on factory floors. We have network sensors that enable monitoring of facilities. We have 3D printing that creates customized goods. We are surrounded by a world of opportunities. And these opportunities will only get larger as we start to imagine what we can do with advancements in AI and robotics. Just picture a world where routine tasks are taken off your plate. Fresh produce might show up on your doorsteps delivered by drones. Garbage bins might take themselves out, and smart infrastructure systems might support automated pickup. And AI assistants, whether embodied or not, might act as your guardian angels, providing advice to ensure you maximize and optimize your lives and you work effectively. These capabilities, this potential future is enabled by the AI brain, which is the collection of implemented algorithms that provide support for cognitive tasks by delivering autonomy at rest and for physical work by delivering autonomy in motion. And in order to get to this promise, advances are taking place in three fields simultaneously. We have robotics, which puts computation in motion and gives machines the ability to move. We have artificial intelligence, which gives machines intelligence. That means it enables machines to see, hear, and even communicate like humans. And we have machine learning that aims to learn from and make predictions on data. And every field that has data can benefit from these technologies. Every field that has a certain level of predictable motion can benefit from these advancements. Now, when it comes to robots, it's important to understand that for robot applications, we have machines that have a body. The body defines the range of capabilities that machine has. We also have a brain. The brain of the machine makes sure the body delivers on what it's supposed to do. So when we think about robots, we have to think about both the body of the machine and the brain, the collection of AI and machine learning algorithms that are inside the brain. Now, as I said, all fields that have data can benefit, and I like to highlight this by showing you an example from medicine, where machines today can look at more radiology scans in a day than a radiologist will see in a lifetime. And an AI-based approach was tasked with reviewing images of lymph node cells and classifying them as cancer or not cancer. On its own, the system had an error rate of 7.5%, worse than the human's error at 3.5%. But when the AI system and the human reviewed data together, the error went down to only 0.5%, which is 80% improvement. And it's important to keep in mind that many applications will be improved by machines and people working together, with people doing what they're best at and machines doing what they are best at. Now, the successes we hear today, we read about in papers today, many of the successes are due to machine learning, and in particular to a technique called deep learning. And the idea behind deep learning is to use data, usually millions of hand-labeled examples, such as this picture in this image, which might include things like this is a beach, this is a palm tree, this is a sea. These examples are used to determine the weights that correspond to each node in a convolutional neural network, so that when a network is used with new input, it will label it correctly. For example, in this case, you have an unlabeled image that gets presented to the network and the system says beach. Now, this works in a couple of phases. For image data, we have a first phase of the process that groups together all the pixels that correspond to the same object. And then the second phase is about recognizing the object and labeling it. Image segmentation, the first phase, can be done automatically, and we have technology that is pretty good at doing that. However, object recognition and labeling is still done manually by thousands of people working in offices like this one. And so it's a very labor-intensive activity. So we have looked at images as one type of data. Another type of data is text. We are surrounded by a wealth of text, and natural language understanding has been making huge progress recently and is developing solutions to a wide range of problems about language. Now, these capabilities impact topics such as automatic translation, creation of chatbots, text summarization, and so much more. So when we look at processing these two classes of data, images and natural language, what we see is that the specific machine learning architectures vary across the fields, vary across the kind of data that we have. And the typical convolutional pipeline model, you can see at the bottom of the screen. At the top, you can see the typical transformer pipeline, which is what natural language processing models use. A transformer is basically a language predictor. You feed it some content and it guesses what might come next. And training transformers to be increasingly more accurate has been made possible by extensive data and by computation. Now, this summer, the OpenAI community introduced a new transformer, the GPT-3. And this transformer was trained on roughly 500 billion words, almost everything ever written publicly. And this transformer consists of 175 billion parameters. And the training cost was approximately $4.6 million in electrical power. But this transformer has become a milestone. It's become really powerful in generating text and answering questions, like you see in this picture. So here we're looking at a conversation where the stream starts with a question: what is your favorite animal? The transformer says, my favorite animal is a dog. Why? Because dogs are loyal and friendly. What are 2 reasons that a dog might be in a bad mood? And then the answer is if it is hungry and if it is or if it is hot. So you can see that this text generation is really extraordinary, and this is creating an entire revolution in chatbots. In fact, a company called Lemonade IPO'd this summer after only 18 months, and the valuation went through the roof. This company is using a chatbot, a powerful chatbot, to make insurance operations easy. It's through Lemonade, it's very easy to set up an insurance policy and then to set up a claim. In fact, my students are using the system and they said it's absolutely seamless and super easy. So chatbots are really being enabled by this technology. Now, chatbots work because we have a lot of interesting well-marked language data. I want to give you an example of a domain where we don't have language data. And this is a new project from my group that in fact goes back to 2009. In our new project, we are trying to decode the language of whales so that we can figure out what they say and how we can talk back to them. And my interest in this area goes back to 2009. This is the time before the world knew what a drone was. When I connected with Roger Payne, a very famous whale scientist, and together with Ascending Technologies, a company that was later started by my students, former students, we went to Argentina where we used the drone for the first time, and we used it to collect a lot of image data about whales that has been truly unprecedented. This data has given marine biologists extraordinary information about how whales behave close up. Now, recently we started looking at whether we can figure out what whales say to one another, and this is what whales found in the ocean. Now, you can hear a lot of noise. Using AI, we are able to remove some of that noise, and we're able to analyze the sounds to try to identify what might be the syllables and what might be the units of speech used by whales. Then we have to figure out what those units mean. The point is that through this technology, we can open up so many more avenues of investigation. And this is a particular example where we don't have unlabeled, where we don't have labeled data. There are so many companies and so many data sources that have unlabeled data. So in machine learning, we have two categories of algorithms. One that works when there is labeled data. So here we have examples of the concept, positive and negative examples, and then we can automatically predict what a new data item is. We also have unsupervised learning, which is what we are adopting in the case of the language of whales. And here we don't know what the various data items are, but we can identify underlying features that leads to clusterings of different groups. So there's tremendous excitement and possibilities, but we also have limitations in what we can do with these technologies. If you look at this slide, you will see two images of dogs. They look very similar, but in fact, the second image is computed from the first image by injecting a little bit of noise that is imperceptible to the human eye. This is sufficient for tricking a trained model that correctly labels the first image as a dog to label the second image as an ostrich. We also have our other limitations in AI, and in particular, those limitations fall in the space of reasoning. Just look at this picture where an 18-month-old child sees this task for the very first time. This child is able to figure out what the person is trying to do, is able to open the closet and almost make contact with the person as though saying, did I understand you correctly? We don't have machines that are able to do this sophisticated level of reasoning. So we have AI challenges primarily around data availability. This means how do we aggregate extensive data sets? We also have how do we manually label? What is the cost of labeling? We also have challenges in the space of data quality. How is your data biased? Because bad data translates to bad performance. If you have bias in your data, you will have bad performance and bias in your computations. The models are really huge, as you saw with GPT-3. Computation can take a lot of time, and so that's another important challenge. Moreover, when we see these big neural network models, they are like black boxes. It's difficult to understand what is happening inside a network that has billions of parameters. It's also impossible to identify whether the network will identify correctly the corner cases and failures. The function is sometimes brittle, as you saw in the dog example, and the reasoning is shallow, meaning that if I had a system that can translate what I'm telling you now in English into French, that system might do an excellent job at mapping my English words into French words, but the system will have no idea what I'm saying. So these are some of the challenges, but at the same time, we also have opportunities. First of all, the AI community is working on all these challenges and making progress. And this is leading to new models. It is leading to algorithms to improve the data quality. It's leading to algorithms to improve the computation that's needed, among others. And we see huge opportunities around customization, around using chatbots, around using machines to augment and support people. And now for the rest of the talk, I would like to give you some examples of some of this work. I want to start with transportation. So in transportation, there are many businesses that are trying to get to the market with self-driving vehicles. This is an example of a self-driving vehicle from MIT. It's a regular car instrumented with a lot of sensors. Now, most of the current solutions use the standard autonomous vehicle pipeline, which starts with data from sensors that addresses that collect information to address what is happening around me. And then we have algorithms to identify where the obstacles are. We have algorithms to identify where the car is relative to the obstacles. We have algorithms about where the car should go. And finally, algorithms for actuation. And so the solutions that we need in this respect have to be hand-coded for each of these boxes in the pipeline for different driving conditions, for nighttime driving, for no lane markings, for rainy weather. Each one requires different parameters, different tuning. As compared to that, we can ask the question whether we can learn directly from raw sensor data how to behave, and we can do so in a way that is independent of the environment. This is something we have been working on at MIT. We're looking at learning from camera data and mapping that directly to driving, to steering commands. And here you can see one of our solution. This vehicle was trained in Cambridge around MIT. So it was trained in an urban environment. And now the vehicle is going to operate in an entirely different environment in a rural setting. The vehicle uses a topological map, and the algorithm is able to drive the vehicle to the goal, helping the vehicle localize and recognize when the goal is met. Now, if I look inside what is inside the engine that is driving this vehicle, I can represent to you in this movie what is happening. The small boxes in the center are convolutional layers that help the vehicle process the camera image. The big rectangular box with yellow, green, and blue dots is the reasoning engine, the machine learning engine that is helping the vehicle decide what to do. You see in the lower right corner the path of the vehicle. You see in the upper left corner the image from a webcam from a dashboard cam for the vehicle. And then in the bottom left corner, you see the attention map. That means where is the network looking in order to make decisions? And you see that the situation is kind of all over the map, and it's very difficult to see what is happening in this box of yellow, blue, and green pixels. And by the way, that is a compressed representation because this network has over 100,000 nodes. So as compared to this, we have looked at different models for creating neural networks. And here in this video, you see the big box replaced by a network that includes only 19 nodes. And this new network was created by replacing the function of a neural network, which is a simple step function in traditional architectures, with a differential equation. Now, when we look at the performance of this network for the same task, we can clearly see what neuron is doing at any point, what each neuron is doing at any point throughout the process. And we can see that the attention map, it's much cleaner. It's not focused all over the map. So this is an example of work that uses new models to address the black box interpretability function of the networks. And these new models are going to have increased impact on the types of applications that we enable. So this picture summarizes on the left before, on the right after. So the old model versus the new model. We can also increase the quality of the data, and in the context of the same application in transportation, I want to show you a situation where we are using simulated data to create the kind of data items that are difficult to get in a real situation. So the idea is we take a very accurate high definition set of data, one trajectory, and then in simulation we can change that trajectory, and we can change it so that we can simulate any kind of driving we want, including crashes. And so now with this data, we can train, or this approach to data, we can have much richer, much better trained systems. So this is an example of how we can tackle both the model side and the data side of driving. We still have a way to go to level 5 autonomy. In the meantime, we have a lot of opportunities for doing other things, for instance, logistics, but also for doing applications in other areas. One application we're working on actively with the city of Amsterdam is in creating autonomous boats. We're in the process of building a full-scale autonomous boat that will use the same software, the same autonomy approach as we have in cars, and it will help drive people using water vehicles in Amsterdam. The boat is rectangular. It's shaped so that the boat can actually come together with other boats to form pop-up platforms like what you see in this picture. And these pop-up platforms could be platforms for public transportation, could be pop-up bus stations or boat stations, but they could also be pop-up platforms for markets, for fruit markets, for concerts, and other activities that the humans might map to water. So here's the concept of how it would work. The boats could assemble together to deliver a platform or a bridge that allows the people to get off of their autonomous boats and go on shore. And we can add manipulators to these boats to enable them to form systems that allow for the removal of garbage bins and that allow for other types of infrastructure operations to be moved to water. So very exciting. We can actually enable this this kind of activity for using vehicles. And here you can see an experiment where quarter scale boats demonstrate how these concepts can be realized. Now, in addition to transportation, I also want to say a few words about production. And the reason I want to do that is because this is another space where we are going to impact companies in a significant way. And what we want is to make it really easy to synthesize new designs, to fabricate new machines, new objects. And my example is of a user I like to call Alice, who I want to give power to automate many tasks in her home. Say she wants a playmate for her cat for when she's at work. To do so, Alice goes to 24-hour robot manufacturing, a new kind of business with a rough idea of what she wants. At the store, she can explore the design space, and when she settles on a design, the store could print the device, and the cat will have a playmate. And so the idea is, we're working on is to have a program decode high-level instructions, like I want a robot to play chess with me, to determine behaviors like pick up a piece, move piece, and to synthesize a design and ultimately to print it. And here you can see an origami robot that has been designed almost automatically. And it's called an origami robot because it was designed and fabricated flat, and then we used folding to create it. Intuitively, you can see how the assembly and the design works. So let's say you have a three-dimensional object. You can slice it into layers. You can unfold the layers, and then those layers can be cut on a laser cutter very fast, very easily, and the robot could be assembled in a matter of hours rather than a matter of weeks, months, and even years, which is what it takes to make new designs right now. Using this technique, we can turn into robotic systems just about anything in this world. And so, for instance, we could imagine the Sydney Opera House becoming a robot. And if the Opera House were a robot, this is what it would look like. So we can take these approaches, these technologies, to reinvent many of the tools using manufacturing. Here you can see a new kind of robot gripper that is very strong, yet very compliant, very soft. This gripper can lift up to hundreds of times its weight. And by putting sensors on this gripper, we can enable it to pick up a delicate objects like potato chips, which is what it's trying to pick right now, but also heavy bottles like a bottle of water or a bottle of wine. So we're very excited about using these ideas for the future. We can then further take these sensorized grippers and enable new kinds of applications. Here you can see a gripper sensorized, a soft gripper sensorized to detect metal, paper, and plastic. And this could revolutionize the recycling industry, which is very important for businesses, also for our planet. So the bottom line is that we have new approaches that allow us to design objects in simulation, to develop their controllers in simulation, and then to go from simulation to reality in a very using a very fast process. Here's another approach where we're using essentially a set of components and grammar rules, and an algorithm is then able to run on these grammar rules and components to optimize designs for different types of tasks. Here we can see optimization for locomotion, where this is a design optimized to jump over gaps. Then we can have designs optimized for other tasks, for flat terrain, for climbing stairs, for going through mazes, and so forth. And then we can take these designs and the controllers that get synthesized automatically, and within a matter of hours, we can make the corresponding vehicle. And so if we can manufacture much faster, if we can create products in quantities of one, we will be able to transform manufacturing. We will be able to use teams of AI, robots, and people working together to create product templates designed by specialists that can be customized by people at home and can be fabricated locally. So one last example before I close is in the area of surgery. These kinds of robots I have shown you can be built at large scales. We can also build them at tiny scales, and we can use these robots to imagine a future for surgery that requires no incisions, no risk of infection, and no pain. And the task we focused on was to remove button batteries that get ingested by a lot of people annually, over 3,500 only in the United States. And if you ingest the battery, this is dangerous because within 60 minutes, this battery will be completely lodged in your tissue, and then you have to have surgery to get it removed. But what if we take a robot and we encapsulate it in an ice package that is shaped like a pill and has the dimensions of a pill, and then we through this new type of robot, we can get the robots to go to the stomach. The warmth of the stomach causes the ice to deploy. I'm sorry, to melt. The robot deploys, and then the robot is able to pull the battery out using a tiny magnet. It's also able to come back into the body, maybe in the form of a different pill that is now embedded with medicine, or that can go to the wound to patch the wound for some time. These robots are made out of sausage casing. And with this, I would like to stop and point that in some sense, the last 60 years of robotics has led to the creation of a very powerful industrial automation sector. This is the first industrial robot. It was built in 1961. Today we have tens of millions of robots that do extraordinary feats on the factory floor. They are masterpieces of engineering, but they remain isolated from people because they are heavy and dangerous and difficult to be around. The new wave of robotics that we're talking about is aiming to create softer, gentler robot systems that are made out of a different type of material, that are inspired by the natural habitat. Like you see this the soft robotic fish robot, whose soft fish is inspired by the elephant trunk. And so we can imagine a future with robots that come in a wide variety of shapes, that are made out of a wide variety of materials, ranging from the current industrial materials, but also adding paper and ice and food and plastic. And this allows us to really think about a lot of possibilities for the future. It allows us to rethink robotics, moving from the last 60 years, which have been focused on constrained hard robots executing industrial tasks, to a future where we have adaptive soft robots executing more pervasive activities in human-centered environments. And with this, I'm going to stop and happy to share, happy to answer questions.
Thank you very much, Daniela. Fascinating and inspiring overview of what's going on at MIT. So let's invite our audience into the conversation. We'd like to invite all of you to participate and ask your questions via the Q&A functions on the Zoom screen. And while we gather questions, let me ask you, Daniela, the first one, and I'd also like to bring Lisa into the conversation. So all these recent developments, I think, are really powered by convergence of a number of key enabling technologies. What do you think are some of the highlights there? What enabling technologies have really come to the fore in recent years and opening this range of possibilities? And I'll ask Lisa to follow up and explain how the Robo and THNQ index portfolios capture those enabling technologies.
So Jeremie, I think that it's an extraordinary time where we see so much progress, and this progress is accelerating. And so we've already seen much better computing platforms, which are necessary because everything that requires reasoning requires computation. We have seen the ability to generate data. We have seen more reliable and a wider range of hardware components. that is necessary to begin to think about different machines. But we have also seen tremendous progress on the algorithmic side, on the science side. We have seen solutions for map making, localization, and path planning. This is enabling the progress in transportation. We have seen automatic design and rapid fabrication technologies along with control technologies. This is enabling progress in manufacturing. We have seen tremendous progress in machine learning and particularly in deep learning. And this is enabling progress in how we handle data, how we learn what happened in the past, what happens now in the future based on what happened in the past, and what we might do. And this has a wide range of applications to many different industries and sectors where there is data available and there is the possibility of improving operations using these types of questions. And the natural language explosion, so our enhanced understanding of how to do language understanding and how to do object recognition are really powering a wide range of applications.
Lisa, do you want to comment on how we build exposure to those enabling technologies in the ROBO and THNQ ETFs and indices?
Yeah, I think as you kind of mentioned earlier, our strategies aim to capture the entire value chain of robotics and AI with key emphasis on innovative solutions. So companies that are enabling the digital transformation that we're witnessing today are companies like chip processing companies like NVIDIA, Xilinx, and ASML, and as well as companies like Materialize, a Belgium-based company that has 3 decades of 3D printing experience. And they're helping the manufacturing sector accelerate research and development to get the products out more efficiently and improve ROI at the same time. So we also have infrastructure software companies like ServiceNow and Alteryx, powering up AI engines for enterprises to get intelligent insights and enhance productivity. So we capture the exposure of the enablers in various ways. I also think it's important to kind of highlight also companies that are leveraging AI. We also provide exposure to companies like building AI capabilities and growing their AI teams. I think it's very important. Companies in the e-commerce subsector, for example, you'll find companies like Shopify and Wix that are empowering small businesses to build their online presence. And companies like Ocado, the largest online grocer in the UK, is transforming the logistics sector with their innovative robotic solutions using pretty sophisticated AI algorithms today. So the e-commerce subsector obviously has been by far one of the top performing subsectors for us year to date.
And staying on those enabling technologies and the computing side, I see a question from the audience around quantum computing. Is this, Daniela, is this something you see coming through in the near term? I mean, clearly we've made some tremendous progress in terms of the parallel computing and specific chips like the graphics processing units performing really well at the training of AI and machine learning in the cloud. Is quantum something that we can and should count on in the near term?
Well, so let me take it one step at a time. With respect to making diagnosis industry more automated, I think that this is absolutely a possibility for the future. And in fact, there are many efforts to bring machine learning to the diagnostics industry. What's really extraordinary is that with machine learning systems, we can flag patterns. We can identify subtle patterns that are difficult for humans to see. And sometimes by identifying those subtle patterns, we can alert humans of problems even before those problems occur. So for instance, in the medical industry, by looking at the video of a surgical operation, you can the system can actually identify really tiny features that map into the possibility of a blood vessel exploding, bursting, rupturing, and by giving the surgeon just a few seconds advance notice, that can make surgery better. The same idea can be applied to diagnostics, where by monitoring the health of the equipment, by monitoring a lot of data about how equipment functions, we can get early warnings that something might go wrong, and those warnings could also be classified and categorized. So I'm very excited about automation for the diagnostics industry, for manufacturing. I'm also very excited about automation for the diagnostics capabilities in the medical sector.
What about quantum? Do you think quantum computing is coming?
Well, quantum computing is definitely an industry of the future, and it's sort of challenging. So we're not there yet, but we're making progress, right? So the biggest challenge is that it's hard to build large scale machines. We have a lot of interesting algorithms. So in theory, once we have quantum machines, we will be able to do a lot of things because we have good algorithms. But in practice, the machines are small. They have on the order of 80 to 100 qubits. And there's only so much that can be computed on 80 to 100 qubits. So I would say that quantum is definitely one of the industries of the future, but we don't have products today.
Okay. I see a few questions related to the pandemic, of course, and I think it's fair to say that from an investor's perspective, the pandemic has created significant dislocations in the market, but the overwhelming conclusion from the market so far is that we've seen a turbocharging of the digitization of the economy, and the companies that are powering this digitization have generated extraordinary returns in the market. The investors have flocked towards the enabler of the from home world, be it learning or working or simply staying home. And Lisa talked about the e-commerce. I'm curious, I want to ask both of you, and perhaps you, Daniela, first, what really stands out in terms of the impact of the pandemic on the worlds of robotics and AI so far?
So I'm going to quote Satya Nadella, who said that we have seen 2 years worth of digital transformation in 2 months as a result of the pandemic. So at some level, the pandemic has really forced everyone to get empowered with technology, with the digital tools. And that is a good thing for society, because that means we have many more people who are educated and who are not scared of using technology, and who will be adopters of new possibilities, of new activities. We have also seen so much progress in many aspects around the pandemic. So let me start by the doing good part. We've just seen announcements of 2 effective vaccines. And I would like to say that this extraordinary rapid evolution from needing a vaccine to having a vaccine has been enabled by AI and machine learning. Because with these tools, we're able to search and generate so many more possibilities and combinations that are very difficult to do in a physical setting. So machine learning has helped us get to the point where we're going to have vaccines. We also see the use of robots in creating UVC disinfecting machines that help keep spaces safe, in creating equipment for hospitals, in creating low-cost, broadly available ventilators. So the community, the robotics community, has already contributed to making the world safer at this critical time with pandemics. But at the same time, we have also seen results that are empowering various other industry sectors. So we see more desire to adopt routing algorithms that will create more efficient mobility on demand for people, safe transportation. And in fact, the company from MIT called the Routable Company is promoting a very efficient algorithm that is bringing this digitization and enabling activities to transportation. We have seen in the e-commerce sector, we see so much activity where we need to route goods to people. People are no longer going to stores. They want the stores to come to us. We don't yet have robots that will bring us our goods, but I imagine that before too long, we will have those robots. In the meantime, we have machine learning and AI algorithms who are powering the extraordinary efforts in delivery. And I read that Carrefour and other companies are turning their physical stores into warehouses because that is what is needed now. So we see an extraordinary transformation. Ocado is one of the companies leading this transformation. Ocado recently acquired Kindred AI to enable even finer control of how they might use robots to do food packaging for deliveries. And so I'm very excited about the possibilities.
I think the logistics automation has really been a standout for us in not only during those pandemic times, but also in recent years. In fact, logistics automation has been the best performing subsector of the Robo Index since its creation. And companies like Ocado on the grocery handling and the order fulfillment systems are one examples, but there are many other automation equipment and solutions providers around the world, from Japan to Germany to here in the US, that have been great investments so far. Lisa, continuing on that theme, what are you hearing from the Robo and THNQ index member companies in terms of how the pandemic has altered their business trajectory?
Yeah, I mean, obviously you saw that many companies called out the massive acceleration in tech spending from enterprises of all sizes related to that digital transformation initiative. I think the companies were seeing the strength coming from the initiatives pre-COVID, but the pandemic has really caught many of the management team by surprise, and many of them felt they weren't prepared. So we saw the surge of spending occurring in the cloud-enabled services. And this isn't just the hardware spending, but also software spending as well. So to the extent that we believe that the migration to the cloud will continue post-COVID, we expect that spending around AI will only accelerate. I think that if I can make a prediction, that just from looking at earnings results, you could see the bookings numbers, the visibility for next several quarters is very strong, and management team has confidence around their business right now. So you're seeing increase in spending in CapEx and R&D, especially around AI capabilities, and that gives us some confidence that they are seeing some business flowing through. They're trying to use this time to strengthen their technology capabilities for possibly the next pandemic, or to get ahead in the digital transformation initiatives.
And I see a question from the audience that's a little more specific, perhaps for you, Daniela. Which robotic or AI solution that has emerged due to the COVID-19 you find to be the most exciting?
Well, so I have we've contributed a number of solutions from MIT, and I find all of those ideas really important. So the notion that cleaning might change to touchless operations, I think that's really extraordinary. That might bring travel and the transportation industry back to full action. The fact that we have contributed as a community to the development of therapeutics and of vaccines, and these will keep the world's population safe. I mean, I think that's really extraordinary. And then A lot of other contributions have been made on the side of clinical operations. So before COVID, there was primarily one type of mask, this N95 mask, which I have next to my desk at all times. But MIT faculty have reinvented masks, have began to innovate in creating more effective tools for people and for hospital workers. You can imagine another technology that I think is really extraordinary and that has began to be used in hospitals. It's touchless diagnostics. It's the idea that you can send a robot in the room of a hospitalized patient, and you can collect a lot of data about that patient without the need of a nurse to be right there physically interacting with the patient. So this can make hospital operations much safer for everyone. So yeah, so between helping to deal with the situation now, helping to do prevention activities like UVC disinfection, and helping to eradicate the disease, like the work in vaccines, I think that the AI and machine learning and robotics communities have risen to the occasion and have really given to the world. And I'm so excited to be part of some of those activities.
Can we touch on the availability of talent? You being in the education side of the AI industry, we hear from a lot of our index companies that they face challenges in terms of attracting and retaining AI talents, and there seem to be a shortage relative to that world of possibilities today. Not enough AI scientists to help those companies bring new products and services to market. I've heard about a new initiative at MIT, the College of Computing. Maybe you could touch on that, but more generally, do you think we're moving along in the right direction in terms of really expanding the training and education of the right talent?
Well, Jeremy, we don't have enough, and that's why MIT is rethinking education and rethinking how to create education programs that would empower students to know the tools of AI and statistics and computation, no matter what specialty, no matter what field they choose to study in. Because I would say that if you think about just about any field, any industry sector, the ability to be fluent in AI and computing is important. So many fields are making progress due to the new tools. So that doesn't mean that everyone should become a specialist in AI or in computer science, but that means that people should understand the tools. The tools should be part of literacy. We should understand how to use AI and computer science and programming, just like we know how to read and write. And by the way, this is my opinion. This is not the MIT official position. Now at MIT, we see a great need for knowledge in these spaces. And we have recently launched the Schwarzman College of Computing. The mission of the Schwarzman College of Computing is to advance computing as a discipline, to advance computing across disciplines. That means empowering students in other disciplines with the right tools, and also to be responsible about how we use and how we innovate in computing. These are three very important pillars to be considered in anything we do right now, frankly, because we need to continue to advance computing. We need to be able to connect and empower other disciplines, but then we need to do that in a way that is responsible. I mean, disruption without responsibility could lead to bad consequences for the planet. And so, so keeping in mind the impacts of the new tools and of how those tools are used is super important.
Thank you. Well, we've reached the top of the hour. In the interest of time, I think we should call it a stop here. I see a few more questions in the Q&A box. We'll make sure to get back to you offline. And I want to thank everybody for joining us today. I want to thank you, Daniela, for taking the time to share your insights with investors and the ROBO Global community. Thank you again, and we look forward to talking to you soon.
Thank you, everyone, for joining us.
Thank you.